And then what I've done is written down question 5. So the question 5 is I have 25.00 milliliters of the weak acid, and it's titrated with a base, sodium hydroxide, with this molarity. I'm given the information that the equilibrium point is at 22.0 milliliters. So if I had my graph, right, it would look like this. With that is my equivalence point, and that would be at 22.0 milliliters. Right there at the center of that steep slope. But it tells me when 11.0 milliliters added, the pH is 4.49. So here it's going to be there. What's this all about? Well, the pH, this is the, I don't remember the name, Hasselbalch. I'll look it up. The HH equation is equal to the pKa plus the log of the base amount over the log of the acid amount. And remember, since this is HA plus OH minus, it's going to make water plus A minus. And when I'm exactly at the equivalence point, these are equal amounts. And all we have left then is this. But when I'm halfway there, I have used half this amount and converted half of this amount into A. So at that point, the concentration of HA, the number of moles of HA, equals the number of moles of A minus. At that point and that point only, that's at half equilibrium. When I've added exactly half the equivalent amount of HA, I'm at this point. And in that case, I plug it in here. I'm going to take pH is equal to pKa plus the log of base over A. They're equal, so that's equal to 1, and that's the log of 1 is equal to 0. So the pH is equal to the pKa. And so that's the answer to this question. The question is what is the pKa of the acid? Yeah, what's the Ka of the acid? So we'd have to simply take 10 to the minus pKa, and that's going to be equal to 10 to the pH, and that's going to give us what the Ka of that acid is. And you'll use this in your lab in the same way. You'll find out what the halfway equivalence point is, and you can calculate what Ka is.